Hello, so in this video I'm going to be showing you how to use these calipers to measure very small objects. So this is typical of the kind of calipers we use in our labs. It's in millimeters. There are other calipers that we have in inches, like this one, and this one's a little bit more harder to read, but as you can see, this one goes down to 1/10,000th of an inch. We don't tend to use inches in our labs, so mostly we're going to be using these calipers, which goes down to a fraction of a millimeter. It's actually 1/100th of a millimeter. So this here indicates that the maximum range of things that you can measure is 25 millimeters, and the smallest divisions on this scale here that I'm going to show you are 1 millimeter. But you can actually go down to the hundredth of a millimeter. So as an example, I'm going to show you how to measure the thickness of this disc. And so what you want to do is kind of put it in there and then hold it and then turn this knob. And on this knob, it actually has a release. So you can see that if I keep tightening it, at some point it stops turning and then it starts clicking. And once it clicks a few times, then you know it's where it needs to be, because you don't want to tighten it down too much, because then you'll compress the thing that you're trying to measure, which is not what you want. And at this point, I can just take this out and I can just read. I think I can take it out. And now I can just read what's on there. It's a good idea to have a sense of how thick you think this is, just to make sure that your decimal points and everything are right. So that looks like about 1/2 centimeter, should be around 5 millimeters. And if we look at this measurement, I'm going to bring this closer. So on this dial, you can see these small hash marks. These are 1 millimeter lines. So 1, 2, 3, 4, and we're just about at the 5 millimeter line. So it's around 5 millimeters. But now we want to know exactly how much it is. Now in this case, you can see, so it's around 5 millimeters. I guess I'll go ahead and write that down. But what is it exactly? Well, it's actually a little bit less than 5 millimeters, because you can see that this secondary dial here, it has 100 divisions, and we're at about, well, just shy of 90 divisions. But those divisions, each of these smallest lines on here are 0.01 millimeters. So you can see that from 80 to 90, there's a midpoint here. That's the 85 line. And then in between those, there's a bunch of smaller lines. So there are 10 lines in between the 80 and the 90, and there's 100 of these per rotation, which is 1 millimeter. So 100 of those, each of them is 0.01 millimeters. So in fact, you can see here that we're not quite up to the 0 point, so we're actually at a little bit less than 5 millimeters. So it's actually going to be 4 point something, and that something is what we need this secondary dial to understand. There's going to be 2 digits here, and it's going to be 4 point something something millimeters. So then to determine what those somethings are, now we go here and look at this secondary dial. It looks like here's 85 millimeters, and if you can't see it here when you're in person, you'll be able to see it better, but you can see that's 85, and then we want to look for where this horizontal line here lines up with the scale over here. And if you look at it, it's about at 85, 86, 87. I would say that's about 88. So this is 4.88. Oops, bad handwriting. 4.88 millimeters. That's our actual measurement, and it goes out to the nearest 0.01. So that means that on a device like this, what's the uncertainty in our measurement? Well, you could imagine that line showing up just exactly halfway between two of these tick marks. That can happen, in which case, instead of 4.88 or 4.89, I might have something like 4.885. Halfway in between 88 and 89. So you actually can go down to the nearest 0.005 millimeters. In other words, you could be halfway between two of the tick marks. If you're right on a tick mark, you'll be here. All right, you'll be at 4.88 or 4.89, but you could be halfway in between in some cases where you're 4.885, for example. So the uncertainty in this measurement is at best 0.005 millimeters, 5/1000ths of a millimeter. So that's pretty precise. So let's do another example. Imagine we want to measure the thickness of this piece of paper. So I'm going to take this, put it in there, and you can look up what the actual thickness of a piece of paper is supposed to be, and they're pretty precise. So I got the clicks there. I'm going to pull this out, and I'm going to make that measurement, and you can see that there's a, oops, I moved it. Let me do that again. Okay. So you can actually see that there's a little tiny gap here, and that is the thickness that we're measuring. So here it's going to be well under a millimeter. So we're not going to be to the 1 millimeter mark or even the 0.1 millimeter mark. So we're at 0 point something something millimeters. And the question is just what's that something? And then we just look at this secondary scale. Remember 100 divisions, so each of these divisions is 0.01. And I can see this line lining up with about the 5, 6, 7, 8, about 9. So 0.09 millimeters, right? So that means that the thickness of this piece of paper is 0.09 millimeters. If I measured it in a bunch of different spots, maybe I'd get slightly different values. And actually, if you look this up online, it should be around 0.1 millimeters for a typical kind of sheet of paper, which is very nice to know, because if you needed to make a spacing of exactly 0.4 millimeters for whatever reason, you could just stack 4 sheets of paper. You could use this information to say I can just stack 4 sheets of paper on top of each other and get a 0.4 millimeter gap. So that's why it's important to know precisely these small kinds of measurements, because they can really help you out.